Hello everyone, welcome back to our channel. So today also we are going to solve some practice questions for k-fold cross validation and leave one out cross validation. So let's get started. Okay, so our first question says, which of the following statements accurately compare or contrast bootstrapping and cross validation? Select all that apply. Okay, so here they are talking about two different techniques. One is bootstrapping and the other is cross validation. So let's take a look at both of these techniques so that we can compare them. So we already know what is cross validation, right? So in cross validation, what we do is, suppose we are doing k-fold cross validation. K-fold cross validation, then we divide the whole data set. Suppose that the data set is of size n into k folds, right? So this is fold 1, this is fold 2, this is fold 3, ... and this is the k fold, and every fold is of size n by k, and we have k folds. Okay, now what we do is, when we are training model 1, suppose we are training model 1, then what we can do is, this is one of the options, we can take the first fold, right? This is the first fold, into testing. So this is test, and rest of them we can take into training. So from 2, 3 up to k we are taking in training. So, and when we are training model 2, what we can do is, or what we'll do is, we'll take second fold in testing. So we'll use this fold for testing, 2, 3 k, right? This we will use for testing, and the other ones we will use for training. So all these will use for training, right? So k minus 1 folds are in training, and 1 fold is in testing, and we repeat this k times, right? Such that every time just one of the folds come in the testing, and all the folds will come only once in the testing, and they will come at least and only once in the testing. Okay, so this is cross validation. Now let's take a look at what is bootstrapping. So bootstrapping is a different technique from cross validation. So in bootstrapping, what we do is, suppose you are given a data set of size n, right? So now what we'll do is, we can actually do it x times we can do, or say some t times we are doing. Okay, t times we'll do this process. We'll do sample n points from data set with replacement. So what happens is, so when we are given n data points, we'll sample n data points with replacement. With replacement is here important, because it means that some of the points might get repeated in this data set. Some of the points get repeated, and because some of the points are getting repeated, some points will not even come in this data set that we are newly sampling. Some of the points won't be sampled at all. Won't be sampled at all. Okay, so some of the points will not be sampled at all, and some of the points will get repeated. Okay, so how we are constructing the training data and test data from this is, so these points, okay, these points that we got after sampling will be in training data, and the points that did not get sampled in this iteration at all will become the test set for the iteration. So I'll repeat once again. So you have a data size of size n, okay, and you will do these iterations multiple times. Suppose you are doing them t times. Probably I should write this in a better way. We'll do it t times. T times you will do this. Suppose that you are doing bootstrapping t times. So t times, every time you will repeat this. So first step is you will sample n data points from the data set with replacement. With replacement is important because we are doing it with replacement, some of the data points will get repeated. Some of the data points will get repeated and some of the points won't be sampled at all. So in this iteration, the points that we sampled, the n points that we sampled, actually this is not correct. Yeah, so some of the points will get repeated, right? So some of the points will get repeated and some of the points won't be sampled at all. So the data points that do not get sampled at all become the test set for this iteration, and the data points that you sampled here, right, the n data points with repetition, they become your training set. So yeah, so this will become the training set, and these points which did not get sampled at all will become your test set. So, and we do this some t times and we compute the error on the different test sets t times and we just aggregate them like we do in cross validation. Okay, now let's get back to the question. So the question is saying that which of the following statements compare or contrast bootstrapping and cross validation. Okay, and we have to select all that which are applicable. Okay, so A says bootstrapping and cross validation both train models on subsets of the training data, right? So right, this is correct, right? Because this is the training data that we are given. From in cross validation, we are taking some k-1 folds from the data that exists, right, in the training. Even in bootstrapping, we are given n data points, which are the training data. We are just resampling n points with repetition, and whichever points are left from that data, they are used in test set. Okay, so this is correct. Bootstrapping and cross validation actually train models on the subset of the training data. They might not be a proper subset. Proper subset is basically so if you have n data and your data size is n, and the training data suppose is of size n1, right? So proper subset will be when n1 is strictly less than n. So this is the proper subset. Okay, so this is correct. In cross validation, there is no overlap between the subsets each model trains on. Okay, so in cross validation they are saying there is no overlap between the subsets each model is trained on. Okay, so let's look at these two models that we have written down here. So model 1 is being trained on subset or the fold 2, 3 and up to k, and model 2 is being trained on 1, 3 and up to k, right? So there is definitely an intersection, right? So intersecting folds, right? Here you can see clearly that they are intersecting folds in training. Okay, so this is not true. The statement B says that in cross validation there is no overlap between the subsets that each model is trained on. This is not true because we saw that the models are trained on k minus 1 folds and we do this k times, so definitely there will be overlap. Okay, let's go to the next statement. Bootstrapping and cross validation are both methods to estimate prediction error. This is correct, right? So the goal of both of these exercises can be that you train the models on different data sets either by sampling with repetition or by creating k folds, and in the end we test all the models that we have trained in bootstrapping and cross validation and we compute them on test sets and we take the error, the aggregated error or the average error, and that's usually the estimate of the prediction error or the estimate of the error that our models can make on unseen data. Okay, so this statement is correct. In bootstrapping, each model is trained on the same number of data points as the original training data set, unlike cross validation. This is also correct, right? Because we just saw that the data set given to us is of size n. So this is usually the training data. So I will just add this point here probably. Yeah, and we sample n points from the data set with the replacement, and this makes to a training of the training set of the model that we are training in that particular iteration, right? So this is correct. But in cross validation, actually total data points are n and we train on k minus 1 folds. So we are training on k minus 1 into n by k because each fold is of size n by k, these many data points which is less than n. Okay, so this is correct. In cross validation, each learned model is evaluated on non-overlapping subsets of the original training set, unlike bootstrapping. Okay, so this is correct, right? Because we said that every model will have one of the folds as the test set, right? And every fold should be tested at least once, and we have just k folds and we have k models as well. So every fold will only make it to the test set once and only once and absolutely one time. Okay, so the models are evaluated on non-intersecting test sets, while in bootstrapping, so the points that are left in one iteration are used as a test set, right? So whenever we sample next time, it can happen that some of the data points that were left last time are in the test set again. So there is no strict condition here. So this statement is also correct, right? So let's take a look at the answers. So the correct answers are A, C, D and E, right? And B is not correct. So the explanation for that is B is not true for k-fold cross validation for any k greater than 2. Oh, I should have pointed this out that this statement is true for when k is equals to 1 and k is equals to 2. So k is equals to 1, this is a special case where you have whole data set as your training data or the test data set. So usually we don't do that. And when you have k is equals to 2, you will split the data into two sets and you will just train two models. One will be, let's do this here. So if you have k is equals to 2, what will happen is you have n points, right? So what you will do is you will divide data set n by 2, right? So you will train first model with training data is, let's call this fold 1 and this is fold 2, right? So you will train with fold 1 and you will test with fold 2, right? And model 2 you will train with training and test, you will train with fold 2 and you will test with fold 1. Okay, and what is the statement says that in cross validation there is no overlap between subsets, each model and train. So only when k is equals to 2, it's a special case that there is no overlap, because there are just two sets. One of the set will make to the training set and the other will be test set, so there will be no intersection. I hope this is clear now, right? So let's move to the second question. Okay, so how many models must be trained when using k-fold cross validation to determine which of the three possible lambda values is best for ridge regression on training set with n samples? And you have to assume that n is the multiple of k. Okay, so what is this setup? So they are saying that they have to determine which of the three possible values of lambda for ridge regression is appropriate. So this is a case of hyperparameter tuning. Hyperparameter tuning. So the setup is talking about hyperparameter tuning, and we have seen in the previous video that k-fold cross validation can be used for hyperparameter tuning, right? So they are saying how many models must be trained using the k-fold cross validation. Okay, so we know that the algorithm is like this. So for every lambda in lambda 1, lambda 2 and lambda 3, we'll do cross validation. Okay, right? We'll do one iteration of cross validation. Now let's see one iteration of cross validation, how many models we have to train. Okay, so we know that, so they have given that total data set points are n. Okay, these are n data points, and we are using k-fold cross validation, right? So k-fold cross validation, right? So we know that in k-fold cross validation we train k models. Cross validation, we train k models, right? So one iteration will do k models. So one iteration of this. I will write it with a different pen so it's visible. So this is k models. Okay, so now we are doing it for every lambda in lambda 1, lambda 2 and lambda 3. So there are three values of lambdas. So for every value of lambda we will train k models. So for three values of lambda we will train 3k models, correct? So let's go to the answer, and 3k is correct, right? Next question, let's move on to the third question, which is k-fold cross validation is equal to leave one out cross validation on a training set of n samples where k is equal to. So okay, so we had talked about leave one out cross validation, leave one out CV, and we said that it's a special case of k-fold cross validation, k-fold CV. Okay, so let's revise once again what happens in leave one out cross validation. So let me take a new slide. So in leave one out cross validation, our test set has just one sample. Okay, so basically, so now let's go to the k-fold cross validation setup. K-fold cross validation setup. Test set has one fold, which means one fold is n by k in size, right? So here test set is one sample. So we are saying n by k, which is the size of one fold, is equal to 1, right? So what is the value of k? So we get value of k as this, and probably I should write this in another way. So this says k is actually equal to n. Okay, so how many ever data points are there in your data set? If you take that as your k, you are doing leave one out cross validation. Okay, so this is the right answer. Let's see the right answers. By the way, I have been taking these questions from some of the prestigious universities' midterm solutions. So I have linked them below and you can refer to these online. Okay, so the question says that the answer is C and we did it correct. Great. Let's move on to the fourth question. So what is this question saying is, suppose you have picked the parameter theta for model using 10-fold cross validation. So you're saying that you did, so whenever they're saying that you have done the hyperparameter tuning already and you have picked the parameter theta, right? Now they're saying the best way to pick the final model to use and estimate its error is to, okay, so they're saying ki the best way to pick a final model, you have already done the hyperparameter tuning. Okay, so hyperparameter tuning is done. Hyperparameter tuning is nothing but suppose there are multiple parameters in a model and there are multiple values that you want to check, like what configuration for my model works best. So you will just do for every value of that parameter, you will just do the cross validation, and whatever gives you the best average result will be your chosen hyperparameter. Okay, so they are saying the hyperparameter is already done. Okay, now they are saying, okay, you are done with cross validation, now you have to select the final model. So what is the best way to pick the final model to use and estimates its error? Okay, so let's look at these statements. So pick any of the 10 models you built for your model and use its error estimate as on the held out set. Okay, so they are saying that you can use any of the models that you trained in the 10-fold cross validation. So we have trained 10 models because our k is equals to 10 and we trained k models in k-fold cross validation. So they are saying any of the models that you picked, any of the models that you trained in the cross validation, you can pick any of them. So this is not correct, right? Because any of the model, if we pick, it might or not, it might give us the correct estimate or not. In CV, what we do is we take the average of those errors, right? So we should not pick any of the model. Let's look at the next statements. Pick any of the 10 models you built for your model. Use the average CV error for the 10 models as its error estimate. So they're saying ki you can pick all the 10 models, pick any of the 10 models you built for your model and use the average of the CV error that you got on the 10 models or the 10 sets as your error estimate. So this is also something that we don't do in practice. The reason being that so whenever we are training out a model, right, or whenever we are training a final model, we want to use as much of the training data is available to us. While in this case, we have used only k-1 folds of the data. So we would not prefer training our final model with the like having the final model any of the one model from the k-fold cross validation models. So this is not usually what we do in practice. Now they are saying is average all the 10 models you get and use the average CV error as its error estimate. So this is also not correct. So first of all, how do you average all the models? So what you can do is you can take the predictions from every model and you can average out the predictions and you can use the average of the CV error as its error estimate. So like I said, we usually don't do that. Cross validation is used to get the error estimate, like okay, this much will be my error, but eventually we want to train the model on the bigger data set. So we want to use all the folds. Okay. So this is also not correct. Average all the 10 models you get, use the error the combined model gives you on the full training set. Average all of the 10 models you got and use the error the combined model gives you on the full training set. So this is also not correct, because if I'm going to pick all the models from the if I'm going to evaluate on my training set on which the models have been trained, that's not the correct estimate of the error. So this is also something that we don't do. So let's look at the last statement. So they're saying train a new model on the full data set using the theta that you found and use the average CV error as its error estimates. So this is what we usually do, like I have been saying, that once we have estimated the parameter theta using CV cross validation and we have gotten an estimate of the model, estimate of the error, what we do is we train a new model on the full data set, because we want to use all the data that we have available for our training, and then we can use the CV error as the error estimate. So E is correct. Okay, now so they are saying E is correct, right? Let's move on to the last question of this video. So it's a true false question. So they're asking, and this is a very good question. So you can expect these kind of questions in GATE. So they're saying, especially when ISC is the in charge of organizing the paper, these kind of questions can be expected. So in n-fold cross validation, each data point belongs to exactly one test fold. N-fold cross validation, in n-fold cross validation, each data point belongs to exactly one test fold. So this is correct, right? So let's visualize this once, right? So you have fold 1, fold 2, fold, say this was fold 3 ... and these are k folds, right? Or here, because they are using n cross validation, so let me just be in sync with the appropriate notation. Okay, so these are n folds. Okay, in n-fold cross validation, each data point belongs to exactly one test fold, so the test folds are independent, right? So we know that every time we train a model, only one of these will be used as a test set, and all of the n folds should make to test set at least once, right? So we are training n models because we are doing n-fold cross validation, and we have n test sets. We need n test sets, and we have n folds, right? So actually, one fold makes to the test set exactly once. Correct? So this statement, what they're saying is each data point belongs to exactly one test set. So now these folds will have data points, and the data points will belong to at least or exactly one data point test set. So every data point will belong to exactly one test fold. Correct? So they're saying test folds are independent. Are the error estimates of the separate folds also independent? So they're asking a question. So they're saying your test folds we saw are independent. Test folds are independent. Correct? So the question they are asking is are the error estimates of the separate folds also independent? So given the data, in the test folds I and J are independent, and error estimates are EI and EJ, the error estimates on the test fold I and J are also independent. It's a very good question. So they are saying your test sets are independent. Suppose test set 1, or there are two test sets, test set I and there is test set J. Okay. So they are saying each gives error I. This is the error estimate of ith test fold, error estimate, and this is the error estimate for the jth test fold, right? So the question they are asking is, are EI and EJ independent? Okay. So ENI and EJ will be independent if they are coming from some model that is trained independently. So when I say trained independently, their data should be, the training data should be independent. Training data should be independent. Okay. If EI and EJ are independent. Okay. Is the training data independent? For TI and TJ, the test so for test fold I and test J, we should really be asking, are training I and training J independent? We know this, right? They are not, because let's take a look at it again. We saw this previously. Suppose that you have K folds here, and right, this is your model 1, and this is your model 2, or let me call this model I and model J. Model I and model J, right? 1 I J K, right? I J K, right? So I'll highlight test fold with this color, right? So model I, test fold is this, correct? And here test fold is this, right? But see one thing, right? So I is being used for training in model J, right? And J is being used to train the model I. So their training sets are not independent, and hence your error estimates are also not independent, right? Did this make sense? I'll just go over this again. So model I and model J, right? And these are the folds. So we are saying that in model I, and maybe I will use for training fold, I'll use a blue color. So you will see, right? So this is blue, and this is blue, and this is blue, right? And test is this. So you can see in model I is in test and J is in training, right? But in model J, though fold J is in testing, this I is in training, right? So essentially what we are trying to say is, here J is coming in training, J fold here, right, which is being used is a test fold. This is coming in the training of this model, and similarly I is coming in the training of model J. So these are not independent. Okay, so this is false. So this is false. Right? Let's look at the explanation of this. Since the data point appears in multiple folds, the training sets are dependent, right? So training sets are dependent, and thus the test fold error estimates are dependent, right? So this establishes that this is not a true statement. Okay, so that was all I had for this video. Thank you everyone for staying connected with us. Happy learning, and let us know if there are any topics you want us to take on and make videos on them. We'll be happy to make videos on the particular topics that you suggest. Bye. Thank you.